Today we are back to finding slope, but today we are going to learn a formula for how to do it. The other day when we found slope, we had a graph and we counted our rise over our run, or our fall over our run, and then we also had a table the other day where we found the change in the y over the change in the x, but today is different. If you look down here, you see I don't give you a graph, I don't give you a table, I just give you two sets of ordered pairs. And so we're going to follow a formula today for how to find the slope. So before we get to that, let's just review our four different kinds of slope. So let's talk about our slope dude. This line has what kind of slope? Negative. This line has what kind of slope? Positive. Our vertical line, what kind of slope? Undefined. And our horizontal line, what kind of slope? 0. And those are our four kinds of slopes. Okay, talking about some of the things that slope means, and we mentioned this the other day. The first way is the vertical change over the horizontal change. Which is the same thing as rise over run or fall over run. Think of those two things as the same, rise over run or fall over run. And that happens to be the same thing as the change in y over the change in x, which is what we use specifically when we have a table. Okay, so like I mentioned earlier, today we're going to find slope by using a formula. And this is how the formula goes. It says the slope equals y2 minus y1 over x2 minus x1. It looks ugly, but it's so easy. It just tells you to take your ordered pairs, take the second y and subtract the first y. Divide. Take the second x and subtract the first x. Okay? Notice it always is a minus in the middle. So that is a part of the formula. Notice it's y's over x's, which is why it's change in y over change in x. Vertical change, which is your y-axis, over horizontal, which is your x-axis. Same thing as rise, that's what you do in the y. Over run, that's what you do in the x. Okay, so first I'm going to go ahead and label these. The first number is always the x. The second number is always the y. Because this is the first point I see, I call this x1, y1. This is the x, this is the y, and because it's the second point I see, I call this x2, y2. Now I'm going to do exactly what that formula up above tells me. It tells me to write my y2, so my y2 is an 8. Then it says minus, so I put a minus sign. And then it says y1, so y1 is a 3. I put my division bar. Then it says x2, so x2 is a 4. And then I put my minus sign. And then x1 is a negative 2. Now here notice I have a minus and negative back to back. What happens with that? Giant plus. Okay, now I'm ready to just work it out. 8 minus 3 is 5. 4 plus 2 is 6. If I could reduce this, I would, but I can't. So that's it. Our slope is 5/6. And that's how the formula works. It's very simple. Okay, I'm going to go ahead and label these again. My first number is always the x. My second number is always the y. Just like in the alphabet, x comes before y. Since this is my first point, I call it x1, y1. In the second ordered pair, my first number is the x. My second number is the y. And because it's my second point, I call it x2, y2. Now let's just do what our formula says. It says take the y2, and our y2 is a 2. Then it has a minus sign, so I put a minus sign. Then it says y1, so y1 is a negative 6, so I write negative 6. Divide by x2. x2 is a negative 5. Then it has our minus sign. And then x1 is a 7, so I put a 7. Now my numerator, I can clean this up because I have a minus and a negative makes a giant plus. So in the numerator, 2 plus 6 is 8. In the denominator, negative 5 minus 7 is negative 12. Two negatives, you add, you get a negative. Okay, now I notice that I can reduce this fraction. What can you divide both of these numbers by? What's the biggest thing you can divide them by? That's right. Let's divide them both by 4. And if I divide them both by 4, what would my new answer be? 2 over negative 3. I just don't ever like to write my negative in the denominator. I either put it out in front or I put it up in the numerator. And that's the slope of the line that goes through those 2 points. Easy peasy, right? Okay, let's just try a couple more for good measure. I'm going to go ahead and label x1, y1, x2, y2. All right, following the formula, I know you can't see it now on my sheet, but you can see it on yours. I take my y2, which is a 2, and then a minus my y1, which is a 2, divide by x2, which is 5, minus x1, which is a 1. I don't have any minus negatives, so I'm good to go. 2 minus 2 is 0. 5 minus 1 is 4. Do you remember from the other day what this is? What is 0 divided by 4 when the zero's on top? 0 divided by 4. 4 times what makes 0? 0. So the slope of this line is 0. Now, testing your memories, what does the line look like if the slope is 0? Horizontal. Good job. And our last one, folks. Here we go. I'm going to label x coordinate, y coordinate, x1, y1, x coordinate, y coordinate, x2, y2. Following the formula, I take y2, 5, minus y1, 1, divide by x2, 2, minus x1, 2. No minus negatives, so here we go. 5 minus 1, 4. 2 minus 2, 0. What's that? 4 divided by 0. What can we multiply 0 with to get a 4? Nothing. So the slope is undefined. Do you remember my memory device that we talked about the other day? When the 0 is under the fraction bar, the slope is undefined. Under, undefined, under, undefined, under, undefined. Am I annoying yet? All right, what's the line look like if the slope is undefined? Vertical. Good job. We're done for today. Smiley face. Thank you.